Dependence on electricity has become a way of life. Laptops, mobile phones, air conditioners, stoves, televisions, electric vehicles. You get the idea. Our daily lives are using an ever-increasing amount of electricity, but we tend to not think about how much energy each of these things use. At least until we get our electric bill. Out of sight, out of mind. But what if you could tap into the power of machine learning to help you monitor your energy use? To find out where it's coming from and where it's going? To potentially let you know if one of these devices is failing and in need of being replaced. Would you be willing to put that artificial intelligence into your home? I'm Matt Ferrell. Welcome to Undecided. When you get a car that requires charging, whether it's a plug-in hybrid or a full-blown EV, it always seems to send you down a path of wanting to know exactly where your energy use is coming from and how much you're spending. When I got my first plug-in hybrid car about 6 years ago, I started down this path for myself. And it only got more intense when I added solar and a Tesla Model 3 to my home. About 2 years ago, I installed a Sense Whole Home Energy Monitor, which not only helps me track how much energy my solar panels are generating, but also how much energy I'm using, and provides a picture of what devices are using that energy. There are a bunch of home energy monitors on the market that you can use, but Sense caught my attention because of the machine learning aspect of the product. I had a chance to sit down and talk with Mike Phillips, the CEO of Sense, about how this type of system works and how it came about. What is it that got you to start the company? Like, what was your motivation behind it?
It started from this broad notion of people want to be able to save money by saving energy in the house, but they just don't have visibility into where it's going. So that's what we set out to attack.
There's other systems like this out there, but the thing that drew me to Sense was the simplicity of the system, because most of these systems that I was looking at were like, you have to put all these connections on every single, line on your electrical box. But here with Sense, just put 2 clamps around your mains and the machine learning will take care of the rest. Machine learning seemed to be the secret sauce of Sense. Was that your basic approach that kind of pulled this all together?
Yeah, so I also started by putting one of these systems in my house that had the clamps on every single circuit, and it just was too cumbersome. And even then, knowing power by circuit wasn't really what I wanted. I wanted to know what the different devices were doing. So we started wondering, well, if we measure the power in a detailed enough way, can we figure it out just from the power signals? We're making use of the fact that the different things in your home use power slightly differently. So if we measure well enough, can we tell the difference? And sure enough, it's not a new idea. It's called load disaggregation. And there've been tons of research done on this. But what we found was it just was much harder than most people thought it was. Things kind of worked in the lab, but not in the real world, which is kind of how speech recognition was 30 years ago. I don't know if you know or remember what that was like, systems that would work in the lab, but not in the real world. And this is just as hard. And we realized, okay, first of all, we got to get really ambitious about the signals that we collect. So we had very high resolution data. And then just the machine learning problem on top is a tough problem, but we've been deep into it.
I'm not an expert, so my understanding is kind of a base level, but I know there's basically 2 approaches you can take. There's I think you even described it on your website, there's the supervised and the unsupervised paths towards teaching something. Supervised being showing a machine, like, here's a picture of a dog, a picture of a cat, and then you show them a whole bunch of pictures and you tell them when they got it right or wrong, versus unsupervised, where they're figuring it out kind of for themselves. Is that approach for unsupervised a little bit more challenging approach, but with more upside? I'm curious, why one approach over the other?
Yeah, so a great point. And look, it's the case that supervised machine learning is much easier. So if you can get nice labeled data that tells you this is a refrigerator, this is a toaster, and whatnot, that's right. Great. The problem is we can't do that here. Like in speech recognition or image processing, like speech recognition, you can play audio to people, they can listen to it and say, oh, the person said this. Or you can show people pictures of cats and dogs and know that was a cat and that was a dog. Here, you just, for the most part, you can't do that because you show people electrical signals that they don't even know. And, a lot of our users want to help, and it's great to get their help, but they don't know when the condensate pump of their furnace is running. They're just not the so-called ground truth that we can do. So we had to go down the unsupervised learning approach.
As an end user, like when it detects a device in my home and it says, we think it's a washing machine, And then it says, but it could be one of these other things. I'm supposed to pick which one it is. Is that the training of the system, or is there more to it than that? Is there something that you guys are doing at Sense to really kind of shepherd it along?
Yeah, I mean, there's a lot that goes on behind the scenes, and that one particular thing where if we find something that we believe to be unique and we don't know what it is, we can say we found something. It looks like maybe a motor, and then it could, 30% of people call this a blender, 20% of people call it a coffee grinder. You go, oh, it must be my coffee grinder. You type in coffee grinder. It's good. It says that in your app, and then that feeds back to us. So that is super helpful. But some of the other things behind the scenes that comes before that is we can't even show you something in the app until we believe it to be unique, right? Because if we just did this with we found your hallway light, like a 60-watt incandescent in your hallway, and said, great, we found it. But if you also happen to have a 60-watt light in your bathroom, we would get them confused. So we have this really hard part of what we do, which is a uniqueness test, to say, have we found something and are we modeling it correctly, and do we believe it's unique? We have to do all that first before we say, oh, we found something, help us know what it is.
Why do I sometimes see duplicates that show up? Like, it will detect my refrigerator, and then 6 months later, it detects my refrigerator.
Yeah.
I've had that happen on occasion, and I think I have an understanding as to why that happens on occasion, but it's just like, I was curious if you had any insight as to why that might happen.
By the way, one thing I didn't mention on the machine learning side that I think is important to point out, in addition to having to be unsupervised, in addition to having this uniqueness test that we have to do, and wanting to do things in real time, you got to realize the signals are all on top of each other. So it's kind of like doing speech recognition with 30 people all talking at the same time. Yeah. So that's just one more layer of why this is hard. Now back to your question about why do you sometimes get duplicates. I mentioned that we have this uniqueness test to decide, is this a unique thing? Well, sometimes we get that wrong, right? And sometimes we think that what we see now is a different device than we saw before. This is actually quite active internally right now. We're working on that. We know it's a problem, so you should see better performance around that here coming up pretty soon.
That actually kind of leads right into one of the things I was really excited to talk to you about, which was a few months ago, I read in one of your blog posts on your website about the challenges of detecting EVs. Yeah. And as an EV owner, I am super interested in knowing how much energy is going into my car, how much it's costing me. I was curious if you could kind of like expand on what you just mentioned, as well as to the challenges around actually identifying devices, especially things complicated like an EV.
Yeah, so first of all, we are super excited about EVs also, both in terms of be able to detect them and also be able to start to do things like load shifting. We can talk about that later, but it starts with being able to detect them. And look, everyone thinks, and we do too, like they should be super obvious. They're these great big things in your home. We actually made life a bit harder for ourselves, but for a good reason. And that is we wanted to be able to show you things real time in the app, right? There's a big benefit in the app to be able to turn on your microwave, seen it turn on right now and go, that's my microwave. Same with the coffee grinder and so on. So we put a lot of work into making the app real time. And a lot of what we do is focus on how do we make that real time. The reason that makes things difficult now for EVs is when they turn on, they actually don't turn on, in a big, clear way right away. They're very complicated devices inside the car is where the charger is. And they start by, they do a first little test to make sure everything's connected, and then they ramp up in a little slow way, and then they ramp up to some intermediate thing. So there's this kind of complicated dynamic of how these things ramp up and down when they start. And even harder for us is as the battery starts to get full, they start to gradually ramp down their charge rates. So anyway, sorry for all the excuses here, but what it means is trying to show what your EV is doing in real time is a tough problem for us. We're not giving up. I mean, we're increasingly be able to do these things, but still not perfectly. But it's a major focus of our team to better and better do EVs over time.
Where is it happening? Where does the model actually live? Is it on the device in my home, or is it actually being processed out on a server?
Yeah, great question. And at least that one has an easy answer. A lot of your questions have tough answers. That one's an easy one to answer, which is what we call the runtime modeling. So the thing that all day long is saying, did my toaster just turn on? That's happening in the device because we don't want to have to wait and we don't want to send enough data up to the server for doing that. But the thing that says, do you have a toaster, and what does your toaster look like? Because it turns out to do this well enough, we have to not just have a generic model of toasters, which we do, but we also have to know kind of specifically what your toaster looks like. In order to get that real time, we see right now your toaster's turning on. We need a specific model for your toaster in your house. So anyway, that model learning happens server side. So what that means is we send enough data up to both drive the application, but also to then learn what your toaster looks like. And then we push those models back to the device to say, okay, keep looking for that toaster.
One of the things, like I mentioned in the beginning, is my motivation for it was to understand where my energy was going. I'm curious if what you see the average Sense user is saving on energy based on what they're doing, if that makes sense.
Look, we think even in energy savings, there's a lot that we can do over time automatically to really point out where your potential savings are. And that was our first notion, that we would just identify for you where the savings opportunity and automatically tell you. But the first thing we found was that most of the savings are not well-defined categories. Like utilities think it's around light bulbs and refrigerators. Well, that's kind of done. I mean, they're all pretty good now. And meanwhile, there's this big chunk that we just call energy hogs, right? Which is random stuff that if you knew about it, you go, oh, I don't need to do that. I can fix that thing. Right. And it's a really broad range. So it's like, it ranges from you leaving the roof coils on that melt your ice dams and you leave them all on all summer. Or you didn't realize a dehumidifier uses a third of your power. Or there's something wrong with the setting of your heat pump system. Or, the list just goes on. And because it's so broad, we realize, well, we can't automate all that. So let's start by giving consumers just visibility. And then hopefully they'll be like you and actively use the app and the functionality to go track these things down. So that's been kind of the focus, just based on the realization it's so broad. And what we're finding is that if you're really active doing that, you can get 15% or so savings in most homes, but only about half of the people do that, right? So if you average across everyone, it's like half that, right?
I like your examples, because that actually happened to me. I had a dehumidifier that was on a smart system in my garage, and something had happened to the smart outlet, and it wasn't doing what it was supposed to be doing. The dehumidifier was running 24 hours a day, and I noticed in Sense that there was this huge uptick in energy use, and it helped me track down exactly what had happened.
Yeah, and it really is that if you have no visibility, look, if water was running in your basement, you'd know, right? It'd be collecting. You see it. If electricity is leaking, and it doesn't leak in the same way, it doesn't puddle on the floor in the basement, but it leaks in these other ways, you have no way to know. You just have no visibility. So just giving people this kind of direct, real-time visibility where, oh, what's this? They get savings.
I don't think you'll necessarily be able to answer this, but it's because it's probably about future plans. But have you guys considered deeper integrations into other devices? We were talking about load balancing. So let's say my solar system is overproducing electricity. It could automatically turn on my wall charger, the wall connector, to start my car charging. Have you guys considered something like that?
Yeah, absolutely. And we already have a few things that are live today that don't go as far as what you just said, but we've already done integrations with If This Then That. We've done integrations with TP-Link plugs, with Limo plugs, and so we're already using those where we use that to get both a direct measurement of what's going on in the application, and we are able to, in the app, you can control it. So if you see in the app, in the Sense app, that you left your garage lights on, and if it's on the Wemo plug, you can click there, turn off. But the next step of starting to automate these things very much is where we're heading. So in fact, your case is exactly, so in my house, I have solar panels, I have 2 EVs, and I have a very early kind of rigged up version of Sense where it's actually controlling my EVs to only charge when solar is overproducing.
That's awesome.
And if not, it goes and finds the marginal carbon intensity. Now, we haven't productized that yet, just due to priorities. So, but that kind of thing is very much what we're excited about, we're experimenting with, and absolutely is the future.
It's one of the reasons I was excited about the Sense when I got it, was it felt like something that will definitely grow and evolve long term. So I felt like I was investing a little bit into the future of the product when I bought it.
And a lot of these things that we want to be able to do, like you were just talking about, we couldn't really do until we start to get data, and we couldn't really start to get data until we got these things out there. So there is this virtuous loop now where we got, you know, ton of data flowing in, ton of engaged consumers like yourselves, and just more to be done. And now we're kind of limited by how fast we can get the stuff out.
So where do you see, like, not just Sense, but in the broader picture of this type of system, where do you see this going in 5 or 10 years? Where's the end game for you on this?
Well, look, we really do view that kind of your home itself needs to become smarter in ways that it hasn't before. You know, most people, when they talk about smart home, they're talking about, you know, automated lights or their entertainment system automating, which are all fine. You know, I'm not trying to knock those, but that's, to me, just fundamentally different than your home itself or the core systems in your home becoming smart for efficiency, for reliability and safety. You know, things like that, I think, is what's coming and has real benefit to consumers, from saving money, from making their homes more reliable and more healthy. So, you know, I think that's where the opportunity is. It's kind of like what happened in cars. I mean, you know, cars 50 years ago were independent mechanical systems and, you know, carburetors and points that you had to go and tune up every couple weekends. And since then, they became incredibly instrumented and automated, resulting in huge efficiency gains and huge reliability gains. And the same should be true of homes. I mean, homes are harder, right? Because they are built out of independent systems versus built by one, you know, as a system itself. But it doesn't mean that the same principles don't apply, that by making these things smart, we can make these big gains around efficiency, reliability, and convenience.
Whenever I make smart home videos, one of the things I'm always telling people is it's more than making your lights flash green and red by talking to your voice assistant. Yeah. Smart homes have so much more value to our everyday lives than just that.
And look, I think one that's been under explored, even by us also, is even things like health of the occupants, right? Things like air quality. You know, like, do you have a radon fan and is it running at the right rate? Do you have a ventilation system and is it running appropriately? These things will start to be, there's no reason your home can't know things like the indoor air quality and adjust as needed to make sure you're healthy. So, and those are big benefits to people, obviously. So one of the other things that we're excited about and working on that's gonna result in even more doing what we can do today is just getting more details about what's actually in your home. Because right now what we're doing on the machine learning side, on the unsupervised side, is we get these data signals and a little bit of hints from the consumer, but then we have to figure out everything about what's going on in the home, right? If we start to work with like home builders, for example, where they already know what dishwasher is there, what furnace is there, what hot water heater is there, and knowing ahead of time what systems are there, how they're supposed to be working, and now our job is to make sure that they're working as expected. You know, there's a lot more value that we can provide versus our current kind of handle every single house out there case.
So it'd be more curated because you know exactly what's going on ahead of time.
That's right. So that kind of curated, we think also becomes really important for things like performance monitoring over time, right? If you have an air conditioner, maybe it was super efficient when you got it installed. Is it still efficient 3 years later? Well, if we already know and we've been watching it the whole time, we can say, yeah, it's working fine. Or no, it looks like it's been degrading. Maybe the refrigerant's leaked out. Maybe you should have it looked at.
Well, thank you so much for taking the time to talk to me today.
Oh, you're welcome. It's great to meet you.
I'd really like to thank Mike Phillips for taking the time to talk to me. It's companies like Sense that are helping to not only raise awareness of where our energy use is going, but building the foundation of AI systems that can eventually help us know when devices are breaking down and to help keep our homes safe and healthy. With knowledge comes power. Get it? Bad dad joke. Now jump into the comments and let me know if you're using Sense or any system like it. And as always, a special thank you to all of my patrons. And if you like this video, be sure to check out one of the ones I have linked to right here. Be sure to subscribe if you think I've earned it. And as always, thanks so much for watching. I'll see you in the next one.